Hello, my name is Miguel Ángel Muñoz and I belong to the Telco Carrier CSE team at Fortinet. In this video we will show how FortiGate can be deployed in an NSH environment using OpenFV's XCI. This already supports NSH by relying on components such as Tacker, networking SFC, OpenVSwitch and OpenDayLight. So first off, what is NSH? Well, NSH is a mechanism that allows to include additional information in traffic packets, and this information is used to implement service function chaining. By using fields such as service path identifiers or service index, the switches in the network know how to properly steer the packets to the proper destination. Going through each requires service function in the way. These paths are independent and customized for each chain, so the packets may have different paths according to the information included in the NSH headers. What can our FortiGate do with NSH? Well, now the FortiGate is able to understand packets containing NSH headers, and it is able to process its content. For instance, it is able to decrement the service index, and it can also use this information in policies by blocking those packets belonging to chains that have not been provisioned in FortiGate. So in the typical use case, we will have the FortiGate deployed as a standard BNF. Okay, it will be part of one or several service chains. And for this, a couple of interfaces will need to be defined on each FortiGate. One of them will be used to ingress traffic and the other one will be for egress. And of course, it is recommended to have an additional one for management. Okay, the configuration of the FortiGate will be as a virtual wire pair mode for these couple of interfaces. Okay, and we also be very careful if we connect both interfaces to the same network, which will be the standard case. We must be aware of loops because the ARP and NDisk forwarding packets may create a loop on the FortiGate. But we will show later how to deal with this particular case and how to disable this forwarding. So how do we configure the FortiGate with NSH? Well, we have to use the virtual wire pair for the couple of interfaces that we defined before, and we must enable NSH on each of them. Then we have to create a policy, and in this policy we will specify the service path identifiers. And we have to be very careful with loops, as we said before, with the ARP and the ICMP-v6, because they can create loops in our FortiGate. So according to what we said before, we must configure a virtual wire pair for ports 2 and 3, and we have also to configure these ports, these interfaces. We must, for each one of them, enable the NSH and disable the ARP forward and NDisk forward as displayed in the image. So the next thing is to configure a firewall service path, which will be used to set a service path identifier and a service index of the packets that we want to go through the FortiGate. Okay, and then we will use this service path in the next configuration in the firewall policy to indicate that we want the traffic to go from port 2 to port 3, and well, of course we can customize the different action and schedule and services, and we also have to include the source service path that we defined before. And please also know that you can define multiple firewall service paths that can be included here in the firewall policy. So if you want to debug the FortiGate in this configuration, the recommended approach is to run a sniffer. So you will have to execute the diagnose sniffer packet port in both port 2 and port 3, and you will see the traffic going through these interfaces. At the time of writing, there is not a proper printer for the NSH packets, for the packets containing NSH headers. But in any case, you will get a very good idea of what the FortiGate is doing with this traffic, and especially if the traffic is being accepted or rejected by the FortiGate. There are also some tips for debugging that normally help the first time that you are configuring the FortiGate in this environment. So one of the main things that you have to check out is that the FortiGate has been configured both for direct and reverse traffic. This means that the IDs for the SPI for direct and reverse must be included in the policy. Take into account that while the SPI for direct gets a low number, the SPI for reverse gets a very high number, probably the two's complement or a similar approach. You also have to ensure that a policy is created, because otherwise the packet will not be shown. And also a very important thing is that if you want to set the NDIS forward disable in the interface, you have to first associate the port to a virtual wire pair. If you don't do that, the option to disable the NDIS forward will not be available. Another interesting thing to do with NSH is to have different policies using different chains. As you can see in the picture, two different clients can access two different servers, each with their own chain. The interesting part is that the FortiGate can apply different actions or security profiles depending on the chain. In this way, client 1 can get web filter services while client 2 can be configured for anti-malware. We had the opportunity to test this in OpenFV plug test event, and for this we use a simple configuration of a client accessing a server and going through a FortiGate. We ran OpenStack queens with Tacker, networking SFC, OpenDayLight, and OpenVSwitch. Tacker is the top level component, it's the orchestrator, and a BNF manager. Networking SFC is the component in charge of creating chains, and OpenDaylight is the controller that together with OpenVSwitch configures the network to implement these chains. OpenVSwitch is, as you might guess, a software switch running on the compute nodes. This slide shows a global picture of what we will do in the demo. Tacker is fed by the user with BNF and BNF forwarding graph descriptors, and it uses this information to ask networking SFC to implement the chains. Then the SDN controller OpenDaylight coordinates with OpenVSwitch to actually implement the paths that the packets must follow. In this demo, we only implemented a chain going from client to server and the other way around, both going through FortiGate. And finally, we're going to have a look to the descriptors that make this possible. Tacker uses these Tosca specifications to orchestrate what the user wants to do. So the BNFD shows typical capabilities of a BNF, such as the number of CPUs, the memory, disk, and more importantly, the connection points to the different networks, as shown in CP1, CP2, and CP3. The virtual links indicated by VL1 and VL2 represent the networks that the BNF interacts with. On the right hand side, the BNF forwarding graph descriptor shows first a classifier whose criteria is to take TCP traffic for port 80 from a source port to a destination port, and these ports belong to our client and server VMs. They are parameterized and get their value when the descriptor is instantiated. Additionally, this descriptor also creates a chain from connection points CP2 to CP3, both ports of the FortiGate. You can also run the same setup from OpenFV plug test in your own server. First, you need to have an OpenStack running with the same components that we mentioned before, and to do that you have to follow the link in the first bullet. After a couple of hours, you will get your OpenStack up and running, and then you can go to our Fortinet CSC Solutions page on GitHub, where a set of scripts will help you deploy a couple of servers plus a FortiGate, and will set up configuration of every element properly, including the BNF and forwarding graph descriptors. So it's time for a demo. We need to get our OpenStack deployment up and running, and for this the recommendation is to go to our GitHub page, Fortinet Solutions CSC, and select our SFC FGT project. Then if you click on this directory, you will find step-by-step instructions to get the demo live. First off, we need to get OpenVXCI deployment running, and for this we have to follow instruction on this link. The first thing we have to do is to generate an SSH key. Then we have to clone the XCI repository. Then we have to change the directory to make sure we are in the repo. And a very important step, we have to select a commit that we know that works smoothly. For that we use this git checkout command. And after we have set the environment variables, we are ready to start the deployment by executing the XCI deploy script. Then we have to wait a couple of hours until everything is finished. This will leave us an OpenStack environment running with all of the components that we mentioned before. And afterwards, we will be ready to execute our setup script that will bring the FortiGate at the client and the server that will generate the demo environment. So we can see that the deployment has finished, and this means that we have our OpenStack up and running. So we can continue with the instructions where we will go to the OpenFV VM that has been created by this deployment, and inside we will clone the Fortinet Solutions CSC repository that we have shown before, because this repository will contain all of the scripts that we need to finish off our demo. So the next thing is to ensure that we are in the proper directory, and also we have to copy the FortiGate image to this directory. And this FortiGate image must have NSH support. At the moment, this is a special build that we have created specifically for this environment. So we have to continue by copying the OpenRC file into this directory and also to run the setup script. This script will take 5 minutes more or less, and it will execute every OpenStack command to create the networks, the images, the flavors, the client and server VMs, and finally we'll run the Tacker commands to load the descriptors both for the BNF and BNF forwarding graph. Afterwards, it will use those descriptors to create the FortiGate BNF itself and its forwarding graph that will achieve the service function chaining. We will skip the details of this script by accelerating it 20 times faster than its real speed, and instead we will describe the content of the setup.sh file so you can have a better understanding of it. Okay, so if we want to have a look to this setup.sh file, we can find it here in our GitHub account in Fortinet Solutions CSC under the repository SFC FGT, and then we have to go to this OpenFV plug test NSH directory. So this file, this setup file, does a lot of things for us. It creates the network and subnetworks for the private and management networks. It also deals with security groups, it properly setups them. It also creates a couple of images. One is for the client and the server, and in this case we are using this SFC and NSH phraser, which is downloaded from the artifacts in OpenFV. And then for the FortiGate we need this special Q code to image. This is a special build obtained from our engineering guys, which includes specific support for having NSH. Then we have creation of flavors. One is for the FortiGate, the other one is for the client and server. And then we create a client VM and a server VM. These are normally created with OpenStack server create commands. This is not handled by Tacker. Okay, so in the next step, Tacker comes into the scene. We have to install the Python client. And then the next step is to register the beam into Tacker. I mean, we are registering, we are basically telling Tacker that the beam is OpenStack. And there is a config file for that, which is already present in this repository. So the next thing to do is to create a descriptor, a BNF descriptor for the FortiGate. The template is already there, so we don't have to modify it. It is already set up for this demo, for this example. And in the next command, we actually create this instance of the FortiGate. Okay, we have to refer to the BNF descriptor previously created, and that's it. So after some time, the FortiGate will start up and will be a normal standard VM working. And then we fetch some values, the client IP, the server IP, the ports, because we will use these parameters to configure later the rest of the demo. So we also have to create a descriptor for the BNF forwarding graph. Okay, again, the file, the configuration file for this forwarding graph descriptor is present in the repository. And in the next step, we actually create the forwarding graph. Okay, we wait for some time. We ask the controller about the IDs of the service path indicator, both for direct and reverse path. Okay, and then in the next step, we have to configure the FortiGate. So we have to load the FortiGate configuration that we have customized according to the previous values into the FortiGate. Okay. We need to wait a little bit of time, so that's why we have this while loop here. And then we also have to set up the IPs and the MAC on the server and the clients for the ARP. We do that by means of these commands, and after some time we have the demo up and running, ready for our purposes. The script finalizes with some useful, by showing some useful commands to access the CLI of each element of each server in the network. We can also have a look to Horizon just to get a global picture, a global idea of how everything looks in the deployment so far. We have the network topology view here. Let's make it a bit bigger. So we can see that there is a FortiGate instance which is connected to the management network with one interface. And we also have the client and server which are connected to the private together with the FortiGate. And the FortiGate happens to have a couple of interfaces for ingress and egress of traffic. And the service chaining will happen here between the client and the server going through the FortiGate, as we stated before. So if we resume our previous activities with the console, we will have to open 3 different terminals, one for the FortiGate, another one for the client, and another one for the server. The intention here is to finish off the configuration of the demo by creating a simple HTTP server and issuing some traffic to that server to check that it goes through the FortiGate with a proper policy. Now we will start with the FortiGate. We will check first that the firewall policy is in place and that it has been loaded properly by our script. So we see that there is a policy from port 2 to port 3 accepting the traffic and using a couple of different service paths. We can check these service paths that will contain the SPI for the direct and reverse paths. These numbers have been obtained from the SDN controller. We will leave also the console, the FortiGate console, sniffing the traffic on port 2. From the server console, we can get the IP, and we will run a very simple HTTP server in Python that will be listening on port 80. And from the client, we will issue some wget requests towards this server. We can see that the request succeeds, and we can also check the traffic in the FortiGate console. At the moment, there is not a proper printer for NSH packets, and that's why the FortiGate console is showing this Ethertype 0x894F printer hasn't been added to the sniffer. This will be hopefully solved in the next releases. Let's also have a look to the configuration of the system interfaces, just to make sure that they are configured according to what we said in the slides. So we see that the port 2 and port 3, they are configured with the ARP forward and NDIS forward set to disable, and also the NSH has been set to enable. Another interesting test is to go to the firewall policy configuration and to set the action to deny. With this, the FortiGate will be blocking the traffic going through it, and this ensures that we have set up the demo properly and that the traffic is not going directly from client to server, skipping the FortiGate. This means that the classifiers, the chains, the paths, and everything has been properly set by Tacker, OpenDaylight, and the switches. And just to finalize, we can also have a look to this status.sh script that will give us a very quick overview of the OpenStack installation. The first output returned by the script is about Tacker, and we can see that there is a BNF forwarding graph and its descriptor already created. We have also the FortiGate BNF and the descriptor associated as well. And then this continues with the typical OpenStack resources such as the images, the servers, the flavors, subnets, networks, routers, and ports. So that's it. Thank you for watching, and I hope you enjoy the demo.